Hello, everybody. This is Mr. Cat. I am going absolutely cuckoo in quarantine. Miss you guys, but hopefully these videos after Dr. Oliver is teaching or using this as teaching would we're gonna always post these. So remember, go to your homepage and all these videos are available. So before your next quiz, if you're having any trouble or you're having any trouble understanding it, please make sure you go to our homepage and check out these videos. Shout out to Steven, shout out to Destiny, to Sweet, to all the people that are watching this at school. And I miss every last one of you. So anyway, let's get going. All right. So in the last unit, we talked about a lot of vocabulary. We talked about scale factor, scale drawing, and if you remember correctly, we used a lot of these words a lot. So understanding the vocabulary is really, really important in doing well and really understanding this. So the two words that we're going to be really using the next 2 weeks that you really have to understand are number one, constant of proportionality. That seems like a very, very crazy word, and but it's really not that complicated of a concept. And then also proportional relationship, which you're going to hear described a bunch of different ways. But these two words, I want you to start, well, you don't know necessarily what they are yet, but once you hear them, I want you to start using them in your descriptions of things. As you talk in class, as you write answers to things, these are going to be your kind of bread and butter. These are going to be the things that you really use. So anyway, constant proportionality, proportional relationship. Right? And I'm going to talk quickly about what those two things are. All right. So yesterday, we went through basically looking at tables. This table is an example of a proportional relationship. Now, a proportional relationship is basically a relationship which uses multiplication or division. Okay, it's not addition or subtraction. So we talked about yesterday that you can either, like if you go from 60 to 120, it's times 2. And that same times 2 is over here on the left. You can see it says times 2 and times 2. So that represents a proportional relationship. But you could also go across because 1 times 12 is 12, 3 times 12 is 36, 5 times 12 is 60, and 10 times 12 is 120. So if you're noticing that whether you go across or you go up or down, you're multiplying by the same thing, that's going to really be a proportional relationship. Now, one of my teachers said to me, she said, it really just makes sense. So this problem is about ordering a certain number of cases. We did this yesterday. And when you order one case, you get 12 paper towels. Well, when you order 3 cases, if every time you order one, there's 12, well, you would expect that if you order 3 cases, there'd be 36. That makes sense. It's every single one, you have 12. So 2 would be 24. 3 would be another 12, so they'd be 36, or 12 times 3. And everything in this table just kind of makes sense. It doesn't, you have the same number of paper towels, and it doesn't matter if you get 1 roll or 10 rolls. Every time you have another one, it's going to be another 12 rolls. So this just shows you that it kind of just makes sense. And we're going to talk a little bit about this in the future, but a lot of you remember the word from 5th and 6th grade called the unit rate. A unit rate is when no matter which one of these in the table, sorry about that. Get rid of that. Whichever one you're talking about, whichever row we're talking about, whether it's 3 and 36 or 5 and 60 or 10 to 120, every one of those reduces back down to 1 to 12. So the unit rate would be when you have one of something, you would get 12 paper towels. So every one of those, if you made them fractions, see this 10 and 120, the fraction 10 over 120 would reduce, if you divide by 10, would reduce to 1/12. So every one of these has the same unit rate. Now, the other thing you need to know is when you go across, no matter which row you're in, it's going to be times 12. That 12, not going up or down, but when you go across, that 12 is the constant. I'm going to write COP, but really that stands for the constant of proportionality. Constant of proportionality is just the number that you go from the left side to the right side, or we're going to talk about this later, but from the X to the Y. Don't worry about that yet. But what you're multiplying to get the new answer would be the constant proportionality. In this case, it's 12. All right? So first things first, the first thing hopefully I said the first thing you're going to learn today, but hopefully you learned what we just talked about, or that's something new. But another thing that we want to talk about first is you might have tables that have fractions in them. And when you have tables with fractions in them, it becomes a little more difficult to fill in the rest of the table. But one way that makes it really helpful for us to fill in the table is if we get something to equal 1. So in this case, we have 12 tablespoons of chocolate syrup for 1 cup of milk. Now, as long as I'm multiplying by the same thing, this would represent a constant, it would be a proportional relationship. But in this case, it would be a very tasty proportional relationship because no matter what row we're in, as long as we're doing the same thing, and as long as this is proportional, even though I'm using different amounts of syrup or milk, all of these are going to taste the same. And the reason they're going to taste the same is because this represents a proportional relationship. I'm not doing different things. I might have more or less of something, but I'm going to be doing the same thing. But the one thing that's really helpful is if you get it equal to 1, it's very easy to multiply because 1 times what would get you 1/8? Well, 1 times itself would equal 1/8. So whenever you're multiplying by 1, it's very easy to multiply because you just have to, I did it again. You just have to multiply by whatever you're trying to get. So like if I want to know what times 1 gets me 1/4, it would just be times 1/4. So being able to bring something to 1 is really, really important when working with proportions. Now, when you have an answer, so this would be an example, and then we're going to give you a couple on your own. But when I have the number of people and the amount, I said subs, which are just sandwiches. If I know 5 people, we'd have to order 12 subs, and I want to fill in for when I have 6 people, 7 people, or 8 people. Yes, you can do what we talked about before. You can say, what do I multiply by 5 to get to 12? You could do that, and then you could do it for the 6, and you could do it for the 7. But what's really helpful is if you figure out how many subs per one person. And to do that, you just have to, well, in this case, when you're dealing with whole numbers, you could just say, okay, I'm going to go this way. I'm going to go from 5 to 1. So you're getting smaller, so this is going to be division. So 5 divided by 5 is 1. And if you want to bring it back here, you would just do that same, you got to do the same thing in order to keep it proportional. You would do 12 divided by 5 and you would get 2.4. Okay? Now I know for every one person, you've got to order 2.4 subs. Well, that's going to be helpful because if I want to know how many subs I should order for 8 people, now forget about this dividing by 5. Now that I have for one person, what times 1 gets me 8? Of course, times 8. A lot easier, right? Because when you get it to 1, you just 1 times 8 is 8. And if I take this 2.4 or 2 4/10 and multiply by 8, that's going to get me how much food I should order. I lost my calculator, but so I'll just do it by hand. 2.4, 2 4/10 times 8. 8 times 2 is 6. So you get 19.2. So that's how many subs I would need to order in order to keep it proportional, meaning order the same amount of food, for one person. If one person needs 2.4 subs, then 8 people would need 19.2 subs. Okay? So that's the reason why I'm showing you that, is because sometimes bringing something to 1 is very, very easy. If I have 6 and I want to bring it to 1, I'm going to divide by 6. 6 divided by 6 is 1. If I have 15 and I want to bring it to 1, I would just divide by 15. If I have 2.4 and I want to bring it to 1, could everyone tell me what I'm going to divide by? Very good, 2.4. Hopefully you said 2.4. But what happens when you have a fraction? A little bit more difficult. Now, yes, you can divide by 2/3, but it's sometimes hard to figure out, especially using a calculator, what that is. So what we do is there's a concept in math where if we ever take a fraction and multiply by the reciprocal, you will always get 1. So if I have 2/3 of something and I want to multiply by something and end up with the number 1, you would multiply by 3/2, which is the reciprocal. that will always get you 1. If you multiply by the reciprocal of any fraction, you'll be left with 1. So now what I'd like you guys to do is I have 3 problems up here. Can we pause the video and let you guys figure out what would you multiply 4/5 by to get to 1? What would you do 10/3? And then here's a little bit of a challenge one. What about 4 1/5? And play the video when everyone's done trying those 3 problems. So hopefully you're done now. If you wanted to get to 1 with 4/5, you would multiply by 5/4. If you want to get to 1 with 10/3, you would multiply by 3/10. If you want to multiply, so here's the little trick. I would want to be able to get this. This is a mixed number. I want to get this as a fraction. So a reminder of what you did last year and in 5th grade. You multiply and then add. 5 times 4 is 20 plus 1 is 21. So remember, you multiply these numbers and then add that top number. And then the denominator is just exactly what the denominator was originally, which was a 5. So now that I have 4 1/5 is really the same thing as 20 1/5. So now to get it to 1, I just multiply by the reciprocal, 5 over 21. And that's how you get any fraction down to 1. Now you're going to see later where you're going to need that, but it's a really important skill to know. And let's just do one more just to make sure that you know what we're doing. Can everyone please try this one? What would I multiply by 3 1/2 to get 1? Okay, try one more time. So pause the video and hopefully play it when everyone's done. So first of all, you want to change that to just a fraction. You want to convert it. Okay, so 3 times 2 is 6 plus 1 is 7 over 2. So if I want to get this to be 1, I would just multiply by the reciprocal, 2/7. Hopefully that made sense. All right, so now, if you go to page 104 in your book, you'll see this page right here. We're going to do one of these together, and then you're going to do one on your own. Okay? So there is a proportional relationship. I'm just reading this top right here. There's a proportional relationship between any length measured in centimeters and the same length measured in millimeters. Okay? So this is right here. You can see the relationship. When there are 0 centimeters, there are 0 millimeters. When there are 2 centimeters, there are 20 millimeters. So if I was to make a table of that, I have centimeters and I have millimeters. So 1 centimeter is 10, 2 is 20. So can you see the relationship? What makes this proportional is every time you're multiplying by 10. So it says complete the table. So when the centimeters is 9, the millimeters would be 90. I'm just multiplying by 10. When the centimeters is 12.5, I'm multiplying by 10, you get 125. 50 times 10 is 500. And 88.49, when you multiply by 10, you just move the decimal over one place to the right, you get 884.9. And then it says, what is the constant proportionality? So that's just, what are you multiplying the centimeters by to get to the millimeters? Well, you're multiplying by 10. So you don't write times 10. You could just literally write 10. That's the constant proportionality. Okay? Now, I want you to pay attention. The next question is going to ask you about this again. So remember that ruler. Okay? Now, can you fill in this table, which is on, it would be on the very next page, which must be on, I think it's on 105. Okay? Go ahead, pause the video, fill out this table, and then make sure you also answer question B. So now what you're going to notice is the millimeters is on the left. So when there were 10 millimeters, there was 1 centimeter. When there were 20, there were 2. So you're not multiplying by 10 anymore. You could have done, some of you guys are really good at this, you could have either said divided by 10, or what are you really multiplying by? Remember we did this in the last thing. If you had to say multiplying, you don't really want to say divided by 10, though that's really what it is. You could have said times 1/10. That was something from the last unit. We talked about how divided by 10 and times the fraction 1/10 is the same. So if you divide each of these by 10, you would get 7. You'd get 24.5. Notice that when you're dividing by 10, you just move the decimal point back 1. So if it's 4 and you move the decimal point back 1, you would get 0.4. And if it's 699.1 and you move the decimal back 1, you get 69.91. And then it says, what is the constant of proportionality? Now, a lot of you might have said divided by 10, but kind of like scale factor, you have to put it as what you're multiplying by. So technically, the constant of proportionality is 1/10. You couldn't say 10 because that would mean times 10, but you're really dividing by 10. All right. Now, last one. Can you guys try? I want you to almost but actually, before you do this, let me explain. It's totally allowed to have a 3 table, like a time, distance, and then you could have a third column for speed. But speed, just so you guys know, speed is always the distance divided by the time. So once you get the first 2 columns, you can always find out the speed. So if you go 550 miles in 1 hour, the speed is 550 miles per hour because you're only going 1 hour. Okay. So next, you want to be able to fill out this table. So remember, we want to know what are you multiplying by to go from one to the other. So it's basically talking about it going at a constant speed. That's the constant of proportionality. So you can see, how do you go from 1 to 550? Well, you're multiplying by 550. But if you're going the other way, you're actually dividing by 550. So the first thing I'm going to do is I'm going to get this answer right here by doing 330 divided by 550. And you get 0.6, 0.6. Now, when you get 0.6, you also have to figure out, that's 0.6 hours. So we have to figure out what 0.6 hours is. So first of all, it's 0 hours. And then what would 0.6 be in terms of minutes? So since there are 60 minutes in 1 hour, I'm just going to multiply 60 times 0.6. And that's going to get me how many minutes 0.6 is. And when you do that, you get 36 minutes. So this would be 0.6 would actually be 0 hours and, let me go ahead and erase it. 0 hours and 36 minutes. So if I want to know the speed, when you're doing miles per hour, we are going to use the 0.6 because we want to know, we don't want to know how many miles per minute. We want to know how many miles per hour. So I'm going to do that same thing I did before. I'm going to take the distance and divide the time. So 330 divided by 0.6 would get you that same speed of 550 miles per hour. And remember, it said it was going at a constant speed. So we could go ahead and know that every one of these is going to be 550 miles per hour. Now for the next one, it says 1 hour and 42 minutes. So the first thing I want to do is I have to multiply the hours. Remember, we're multiplying the hours times 550. So I have to take 1 hour and 42 minutes, and I have to convert it to just, sorry about that. I have to convert it to just the number of hours. So remember that when you have 42 minutes and you want to know how many hours, remember 42 minutes is 42 minutes out of the 60 minutes. This will give you a decimal for it's 1 point something. So whenever you have the number of minutes, you just divide by 60, and that gets you 0.7. So this is 1.7 hours. So we're going to take the 1.7 and we're going to multiply by that, remember 550, and you're going to get 935 miles. 935. And then if you divide 935 by 1.7, remember you get that 550. So again, a couple things you have to remember. If you have the number of minutes and you want to convert it to hours, what decimal of an hour? Because there's 60 minutes in an hour, you have to do divided by 60. And if you know the number of minutes, if you have, for instance, in this case, like it's point something and you want to convert it back, you just have to multiply by 60. All right, so what I want you guys to do right now is we're going to do page 108, numbers 1 to 2, and page 109, number 3. Okay? And I want you to fill in the chart. Now, and the only thing, I'm going to give you a little bit of a hint. Do yourself a favor, and you could either change these 1 1/2 to a decimal, Or you are also more than welcome to change it to a mixed number, but since it's just such a nice decimal, 1/2, I would change them to 0.5. So here it says miles traveled at 6 miles per hour. So if your speed is 6 miles every hour and you only went 1 hour, you could go ahead and fill in a 6 here. And once you do that, go ahead and try to fill in all the rest of the chart. Now, for the other thing for homework, make sure you do number 2. You could try that right now. Okay. And then the last thing you're going to have to do for number 3 is Jada and Lynn comparing inches and feet. Jada says the constant proportionality is 12. So remember, there are, for every 1 foot, there are 12 inches. Oops, sorry, inches. Okay. Now, Jada and Lynn are arguing about this. They're saying that the constant proportionality is 12, but the other person's saying it's 1/12. So do you agree with either of them? Explain your reasoning, okay? And think about that and write something down there, and then we're going to go over this. The first thing we'll do is I will go over these 3 questions, or actually, it's actually almost like 4 questions. We'll go over those tomorrow, but try your best to try to get these right and make sure you try to complete all of them, okay? I would say that the most challenging one is this one, but if you change 1 1/3, remember to change 1 1/3, multiply and add, and you'll get something over 3. Sorry, I didn't mean 4. You'll get something over 3. So you should probably convert those so that it's easier to multiply. Okay? And hopefully that helped. Watch this video as many times as you need to. And then we'll go over the homework tomorrow.